Okay, in today's video, we are going to be looking at the possible questions that we can get for Waec Physics Practical 2025. So here I'm going to be looking at question 1, and I have 2 possible setups for the practical based on the materials that Waec asks us to provide. So this is one of the first one, and this is the second setup. So this video is going to be in 2 parts. The first one is going to be for this setup, and the second one will then be for this setup. So you do ensure that if you lay your hands on any of this one, you check over my YouTube channel and the description to find a link to the other part of the video. So we're going to start with this. I'm going to run through this and we carry out the setup. So this is the setup. We have 2 retort stands, a meter rope AB. We have 2 strings of height each, and length, the distance between the 2 strings is D, and we have a mass 100 grams. So let's go through this. You are provided with 2 meter ropes, 2 retort stands, a mass M is equal to 100 grams, thread, and other necessary apparatus. Place one of the meter ropes on the knife edge and determine the center of gravity, C, of the meter rope. Measure and record the mass, MR of the meter rope. So the mass of the meter rope, you can measure that using a chemical and electronic balance. I don't have that now, but I already know the mass of my meter rope. So follow the procedure. Attach the mass M is equal to 100 grams firmly to the meter rope AB at C using a paper tape. So you can see the mass placed. So C is the center of gravity. So we're going to determine that. Then we place the mass at C along AB, which is the meter rope. Then suspend the meter rope by 2 parallel threads of length which is equal to 40 cm each at 10 cm and 90 cm. So on the meter rope, we are going to get this at 10 cm and place this at 90 cm. That will make it 10 cm on this side and 10 cm on this other side. Okay, so we are to set the meter rope into small angular oscillation. So this time around is not horizontal or vertical oscillation, but angular oscillation. So we're going to look at all of that about the particle as it's through the center of gravity. So at point C, that is where we're going to set it into oscillation. Then we have to determine the time T for 20 complete oscillations. And we are going to evaluate T at the period T and T squared. Then read and record the value of D in meters. So this is D. Yes, we are going to record that in meters. And then keeping the D constant. So D must be constant. Repeat the procedure for 4 other values of H is equal to 50, 60, 70, and 80 centimeters. In each case, determine T and evaluate T and T squared. Calculate the radius. Plot a graph of T squared on the vertical axis and H on the horizontal axis. So we are plotting T squared against the length H. So what I'm going to do is I'm going to prepare a table based on these values, and that is the table that I'm going to use to carry out my experiment. So I'm going to pause this now and draw out my table and use that to carry out the experiment. So I'm going to determine the center of gravity. Okay, you can see that it's falling this way and this way, so you don't need to waste too much time on this. Just look for a place that it balances a bit. So I'm going to record this as 49.5. So that's my center of gravity. Okay, so this is my table of values. So you can see that I have H, T, the period T, and the T square. So we're going to carry out the experiment based on the description from the question. Okay, so I have a two string tied to the two retort, and the length of the strings are about 100 cm. So they're about 100, so that I can reduce it up to 80. So I'm going to start from 80, then reduce the length gradually to 40. So that's what I'm going to do. So I'm going to start from the highest and then reduce it gradually to 80. So I'm going to place the meter rule and then take the length of 80. So I'm going to measure 80 cm on this from the point where it is tied. So this is 80. And around this, around this. So then I measure it on the other one from the point where it is tied. This is 80, then I'll wrap it around this also. This is my meter with the mass placed at the center of gravity that I measured. So I'm going to place this here. 10 cm. Now place the other at 90 cm. I'll use my stopwatch to get 20 oscillations. So I'm going to set it in angular oscillation. So I'm going to set it 10 times and have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'll record my time as my time here is 22.50. So I'm going to record that down again by resetting your stopwatch to get time 2 times. I don't have time for that, so I'll just go once. So the next thing I have to do is to reduce the length to 70. So I'm going to reduce the length to 70 to measure 70. So remember that I'm doing it backward. This is 70. I'll have this around once again. Place this at 10 cm. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 19.00. So I'm going to pause the video and work out all of that to get the time. Okay, go ahead for 40. What's the time?
13.29.
30.29. Okay, so this is my evaluated values, my recorded value t in seconds, and the period t divided by 20. So I recorded t to 4 decimal places. Then t squared, I recorded t squared to 3 significant figures. Notice that the point where we do not have up to 4 values, I add zeros to them to make it 4 decimal places for the t over 20, except this. So I'm going to add this to make this 4 decimal places. So I'm adding a 0 to this. So I have that 4 decimal places recorded. So you have to record this to at least 4 decimal places. And the one on the t square, you have to record it to at least 3 significant figures. So that's why I recorded all of this to 3 significant figures. So this ends part 1 of question 1. So we are going to look at part 2 of the possible question that we can also get from part 1. But I can assure you that this question is highly likely to be the question that you're going to get. It's highly likely to be that. And do not forget to support this channel. I am going to add an account number, account detail, UB account detail. So if you are moved by this and you love what we are doing, you can support the channel by giving us a token on the account number that I'm going to display on the screen. So thank you for watching. Wishing you success as you prepare for your Waec physics practical. Stay tuned for part 2.